Alrighty, Rue. So part of what I want to do today is talk about how to think about an application and show you the pieces, like code that you can refer to, but mostly give you a grander idea about how to organize components in a way that is both easy to understand and then move to so that other developers can understand it. And also, in my opinion, having organized code, and this is not necessarily a possibility because I'm going to show you an example of my code and when it's rewritten. But to me, organized code that's easy to follow is the difference between an internship and an entry-level developer job, because it's the difference between, all right, this person knows something about code, but they need to learn, how to scale it into a large application, and then also like, oh, this person can jump in and we don't have to worry about them being sloppy. But in addition to that, I think it helps you think about your programs. So I want to give, this is just a start, an example of, on the left is some rewritten code that I have, and on the right is my original thing. This is actually not that bad, but I'm not going to go through it too much because I want to get started. Mm-hmm. But notice that like the lines don't go on forever and things like that. I found ways of shortening everything and keeping it into compact chunks. So anyways, so if you have your laptops, to follow along, it might be easier if you go to my GitHub repo, which is rfpoulos. And if you go into the repositories, I don't have that much. I have a repository called Clean React, and that's where all the code, you can either do a git clone or just go through the files if that makes it easier. But I will also have it up on the TV. So I do want to focus mostly on redux, but I just have to open it up. Oh, here it is. Oh, silly you don't belong here. Okay. So
what's your, sorry, what is it?
Clean React, and my username is rfpoulos. So if you just search rfpoulos, the user should come up. Into repositories. I should have gotten a direct link for you guys, so I'll remember that. Cool. So what I have here is a little app that I'm going to walk you through that uses Redux and also keeps state local and also keeps components separate and chunked. And all it does, and I think that the kind of difficult thing as you guys come into Redux and some of the feedback that I've heard is that I don't understand when I would use Redux because it seems so easy to just pass the props around, and a lot of that has to do with how small your applications are right now. So I am still going to show you a very small application, but hopefully it'll get to the heart of the kind of data that you might be passing around. Come on. that can be organized. All right. So first, let me just show you what the app does. It doesn't do very much. What is this? Oh, no, that was it. I did have it running. So we're going to go to localhost. It's compiling. All right, so basically what this app does, and I'll show you in the Redux store, and I'll try and make this zoom in. Okay, so basically what happens is that when I type here, if I type a keyword, I put in the wrong placeholder text, it's going to do a Google Places search. This was working this morning, but that's how it always goes. There we go. It does a Google Places search based off of a keyword and your current location. And so basically on the left is the name of the restaurant, and on the right, I wonder if there's a way I can zoom in on this more. There we go. On the right is the distance to it. and then if you click on any of them, nothing too exciting happens. It then does another fetch request for that specific place, where you theoretically could get more data than this, but we'll get to that, and then you have the option of going back. So one thing that's kind of unique about this, to do a Google Places request, and particularly to calculate the distance from a particular person, you need their location. So that's just an overview of the application to kind of give you, like, this is the end goal of what we're going to go through. Now starting on, I like to think things on the app level. I think of my router not just as router, but as screens. Anything that's between your switch statement, and did you guys go through React Router?
Mm-hmm.
Okay, so anything that's between my switch statements is a screen. That's what that component is. And it loads some sort of component that has the whole functionality for that page. So anytime I go to, localhost 3000 or whatever my website is, / in this case, you can see, and can you guys see that? Or should I zoom in a bit? So if I go to /results, /ID, that's one page, and in this case, the home page, which is the actual query page, is just a slice. So that's a screen. But what I also want you guys to get in the habit of is not writing everything in your screen. So if we go to an example, the query page, which actually just has the query and the submit button, and also on that same screen, once it does the fetch request, it loads the results. You'll see if I go to the render function there, now that's a lot of things, right? If you have both an input bar, a button, and then you iterate through, I like to call them cards, you've probably heard me say that before, but basically iterate a kind of data card for every single result. That could have been really long, but notice that for the result cards, which has both, in my case, the title and the distance, I actually have a different component that I've kind of chunked together, and I just pass it what it needs. And so I'm going to go through top down, and then I'm going to start over again and go from bottom up. So if we look at like the result card, and so on the left-hand side, and let me know if all of this is gobbledygook. Okay. So if you look at my SRC panel on the left-hand side about how I organize all my files, I have my normal app.js, that goes into index.js. So basically index.js is the thing that actually gets run, and that's also where I stick my provider around it. I have my app.js, which is basically just my router. So everything that's going to appear component-wise. But then I break up, and these are the things that I've kind of added myself. I think in terms of screens, which is anything that's in the router, redux, which is another way to think about it. I know you've only had one day of redux, but I want you to think of it as kind of a higher order component that you can wrap anything in. So if you have particular data that gets shared across screens, that's a good candidate to put in the redux store, and I'll go into that more. Fragments, I don't think we're going to get into this too much today because I kind of want to keep this to half an hour. But fragments are a way of keeping track of data, even if it doesn't render a specific component. So in this case, location, you might have noticed in my application was used throughout my entire application, but it rendered something both on my query page where I got my results and my individual results page. And so it wasn't that I did a fetch request or something like that for my location. I just created a thing in a fragment that's like, if you look at fragment, it's basically an inbuilt thing in React that's like render nothing. But I was still able to have a componented mount at the top of it that I was able to set up a location watcher. But talk to me about that later, because I do want to avoid it more than I initially planned. So far we've gone through screens, redux, basically a fragment, which is kind of the opposite. It's all data, no rendering. But this is the only thing that goes to the redux store because the location is shared across multiple screens. And then I have components. Now, this might be the most annoying one to do in your applications, particularly when you're trying to get something done in 2 weeks. But if we look at any of these individual things, they are totally dumb components. They're not wired up to state or anything. They expect to be passed props. In this case, if we look at the button, which was the search button, it expects to be passed some text, and it expects to be potentially passed some sort of on-click function, and that's it. And you might say, well, this doesn't seem to save me much time. Like, why would I write my button inside a separate file when I could just write in my screen button, do the search kind of thing? And there's 2 reasons why you would do this, and this is up to you. One is because it allows you to keep more consistent styling across your application. So in most of your applications, you're probably going to have buttons in more than one place. So if you style the button once and then reuse that component, you'll have more consistent styling. And you might even have a folder called buttons that has a small button, a medium button, and a large button. And they're all basically the same except for the styling they use. And you can see that I have localized styling for it. I copied this from some sort of button creator, which is why it looks like garbage. But the point is it's localized styling, and then you can reuse that button across your application. Now, this isn't a good example, but taking the time that you're like, oh, I'm about to type H2 or something, make it a component and style it locally. And the last thing I have is what I call kind of a collection. And the things that are in the collection are what I would call kind of iterable data. So just how I had, for every single result, I iterated a particular, what I call card, and I call it even result card, which is, in my case, very small, but a lot of you will have more data of just the title and the info text. And you'll notice that the actual card itself is made up of my really dumb components. Now, you might, for the sake of time, decide to skip. I'm not literally going to style every single component, but I think it's what should be worth it anytime that you have any kind of iterable component or things like that that's going to be like a results card. You should make that a dumb component held separately from your screen and just think about what it's going to be passed, because if you use it in multiple places across your application, but also it makes it easier for me to read as a separate developer. If I go to your application and I go to your router, I can see, oh, this application is made up of these different screens. And then I can go to your screens and it's like, okay, I'm expecting some sort of query and I'm expecting some sort of iterable results. That's easier to read than seeing H2, div, things, icon. If you keep it separate, it makes it easier to understand kind of the format of it. But also it can help you think about your application. So does that make sense so far? Any of that useful?
Mm-hmm. Yeah, actually.
All right, great. So now I want to get into Redux mainly, because I feel like you guys didn't get a lot of time with Redux, and I'm going to show you a slightly different pattern than the one you did. So this I would actually open up if you, did anyone get to my repository? Because I'll show it up here too. But so if you go to the repository, go into the src file, and then open the Redux one, this is where I want to spend most of my time, because this is the kind of data that you share across screens. A really common one that you would want to share across screens, user data. So if someone signs in, you probably need some sort of information from that user object across many, many pages. And you don't want to do a component did mount or check authentication every single time someone goes to a different page on your application. So in this case, I did location, but I wanted to just emphasize this is why Redux is important, so that you can store all your information in one place, and every single component that needs something from it, for example, user information, user ratings, something like that, in this case, location, can just pull it from that higher order component with a connect function. All right, so if we start with the store, this is pretty simple. All this is it takes my reducer and the dev tools, which I'm sure Chris showed you, but I'm just starting from the top. And then your reducer, the way I do my reducers, I know that Chris had you do switch statements, and that is a very common pattern. Whenever I'm reading about Redux, I see a switch statement. I'm not very good at it because I use a router pattern. So does this reducer look a little similar to you guys? Like where you start with the initial state and then it takes an action, and then you have a reducer in there that takes an action type that modifies the state in your store, and it returns it returns kind of the reduced state. This is something you can copy paste though. So the main thing I'm going to get to is the actions and how to wire it up. So this, both the store and the reducer, this is boilerplate. The other boilerplate to set up Redux is that in the index.js, you'll notice that instead of just rendering app at the bottom there, normally you probably see app, and that's imported. I import the app here still normally, but I wrap it in my provider, which is what gives me the access to the connect function. So basically, provider is what wraps my entire application in my Redux store that then allows the connect function for people to call things. So that should look familiar-ish.
Where are you pulling provider from?
So provider comes from React Redux.
Okay.
So provider, trying to highlight it there.
I gotcha.
Yeah.
Okay.
So you can see that I'm importing it from React Redux. It's under the hood. It's using React's context API, which I don't want to talk too much about.
Okay.
So that's under the hood.
Gotcha.
And I'm still learning about that. But basically, there's providers and consumers. So the provider store is going to equal the store where we keep all our up-to-date state that we're sharing. And then our connect function turns our under the hood, our other components into consumers of that data. But this is all boilerplate. So, and I'd be happy to go through it. What I want to show you is a slightly different pattern from what Chris does. So if you look here, you'll notice I have initial state, which you guys have in your switch pattern as well, correct? You have to set up initial state because your reducer isn't going to understand how to load an application if it's empty. So you'll notice that for my current location, when I first boot up my application before I've received it, the current location is just null. Now, normally people keep this with the reducer. I keep it with my actions because as I'm writing an action, it reminds me to go and write it up here. So let's say I'm making user object. I'm like, oh, I'm making an action that updates the user object. And this is a case where I often do copy paste. So let's say I'm making an action to update my user object, and I'm going to go through this line by line, but eventually you'll get to a point where you can just copy paste it. So our goal is to basically make dispatch actions that can go to our reducer and then have something that we can import into our components that uses that dispatch action. So that's a lot of gobbledygook. So I'm going to go line by line. So the first thing I do is that I do a declaration that basically resolves into the string. Because the one thing that's really annoying about reducers or having, this type is always a string. It means that I could theoretically, instead of doing update current location here in the couple of places, I could do, write the string update current location, which is totally fine. But the thing is, what I like is having the autocomplete. So let's say I did make a typo. Let's say I made a typo in here, and I just wanted to update the string. I could still autocomplete this, which isn't to say you need to do it. I'm just trying to explain what this pattern is. The most important part is going to be this export function and this action function, and also this toString. So we'll get to all that. The next thing that I have in each function, and I'm going to comment this out, because then I'll go through as if we were making that user object. So what we want to export is the thing that when we wire up our connect function, that dispatch action, we want to be able to wire up a particular dispatch action. So that's going to be let, in this case, update current location, always something descriptive. It takes a payload, which is basically whatever I'm sending to this thing, and its type is what this string is, and its payload is whatever is going to be wrapped in that function. It's probably going to be a user object. Payload is a pretty standard term for just whatever is sent to me. Update it into that. And then the action that's going to ultimately be set to our reducers, and also you can see down here on line 20 for the actions, this is our router that's basically, okay, when my reducer is reading what action it should do, this is going to be inside of my object. So it's going to take in a state and an action and return the exact same state. You guys know spread syntax?
Mm-hmm.
Great. The exact same state, and except that current location is going to be updated to action.payload, whatever was sent through that dispatcher. And the last thing is that I set up, now this is kind of a pattern to be careful with, but I'll explain why it makes sense here. So then we set update current location .toString to be what this string was here. So basically this gets used in two places. One, when we do the type, but the other so that the string over here, we want this, because our reducer reads types. So this is the same by making the toString of update current location to string here, which is also the thing we export. It's the same as writing this. So that's why we basically set in line 6, we set a variable to equal the string that we want it to be, so that when we send it through type to our connect function, and here to our router pattern, that they say the same thing. All right, so I'm now going to show what this would look like if we were updating a user object. So we have const, not like that, const update, and this would be, I just noticed that a pattern is that these strings that are the type, they don't need to be uppercase, but this is kind of a standard pattern that I see whenever you're talking about the type for your reducer. It's an uppercase and then use underscores. So update user object, and let's say it's exactly what the variable says, update user object, and then we export, because this is the thing that when we hook it up, and I'll show the connect function, and I call it basically the same thing, update user object equals, so it's going to take in a payload, probably the whole user object, and then its type, and you'll notice that this looks pretty familiar, is going to be the string we just made, so we can refer to the variable that we stored it in, update user object, comma, payload, then we need to come up with the thing that we're actually sending to our reducer, which takes our old state and then applies the action to create the new state. So let update user object action equal, and this is, you'll notice, pretty boilerplate other than the thing that we're changing. So state, and actually I think I'm going to change this to a logout function. Well, I'm not going to change this to a logout function yet, but for example, you could not take in any payload. You could make it empty and then just make the update, rather than doing action.payload, you could make it empty. Current location equals null. Anyways, but I'm going to continue with the payload. And I know this is probably overwhelming, but do you feel like you're following the code?
Following the logic.
Okay,
Yeah.
good, because you'll have the code available, so you can look at it later. So our object action is going to be the thing that we send to our reducer. So it always uses as its first argument the state, which is probably the current state, and it takes the action. And it's going to return whatever the state was, all the state properties except for user object, which is going to be whatever the payload was. So the payload is action.payload. Because the action has both, this is the action on line 14. It has the update user object is the action type, and then payload. And if this looks a little weird to you, a part of spreading is if you put just a variable there and it's supposed to be the thing it resolves to. This is exactly like saying this. Payload equals payload, which is why we typically use that generic term, though you certainly don't have to. Like if I wanted to be more specific, I could be user object, user object, user object, and then this would be action dot user object. Although, yeah, so, well, it would still be action dot, yeah, user object in this particular case. This is one case where I would say stick with the generic. You know, just you're updating this thing, this particular part of your store to this thing. So we send this to our reducer, and not only that, we do update current, update user object dot toString, because you guys know that all variables have a inbuilt method called toString, but we're, instead of doing what it would normally resolve to, we're saying, hey, whenever someone tries to do a .toString method on you, instead of what you normally do, we're going to do this. We're going to turn into the update user object string. And the last thing we do, now actions, which is the thing that gets sent to our initial reducer, instead of doing switch statements, we're doing what's called a router pattern, which is basically storing our functions inside our actions. And so now when we export it, update user object, we also, the function that we're sending is so the function that we want to execute so this resolves to a particular type that gets sent to our reducer through our connect function. So whenever someone does a dispatch action that has the type update current or update user object, our reducer is going to look on this left-hand side and says, okay, which is the one with type update user object? Because these all resolve into strings, remember? And then on the right-hand side is the function that our reducer is actually going to do. In this case, all right, return a spread of our state with except that user object is changed. Update user object. Great. So I'm obviously not using this user object in any place.
It'd be action, right?
What?
It'd be user object action.
Yes, good catch.
So can you explain the update user object to string thing again? What
Sure.
exactly you're doing that for?
So on our left-hand side of our actions that we're exporting, where we see, update user object is the thing that's toString. When we go to our reducer, our reducer is going to look for the kind of type that our dispatcher does, which is always a string. So this would be the same as.
These chairs are awful.
Yeah. I'm also pretty heavy, so that could be it. So if we wanted to, if we got rid of line 13, we made this type update user object. We got rid of this line. This would be the same as, and I already have to be very careful that I do it exactly the same, update user object.
It's just changing the variable into a string.
Right, so the thing that's kind of annoying here is that I have to write it in two places, which makes you more likely to make a typo. So by starting our whole pattern, by doing a string, basically, because we know we're going to end up writing it in two places, if we make it a variable instead, I can tab complete it. And then when I do it down here, I'm not really sure it needs to be in parentheses, but that's what I've done so far. Now I could write it this way, doing the actual just variable, or I can actually set whatever toString is, so that, and what I like about doing the toString method, that like in line 18, is that when I'm doing my actions, it's more descriptive about what it does. I mean, obviously they both say update user object, but it kind of signals to me that we're talking about a particular action.
So, but isn't that like the string has more than just like the type in it?
No.
I'm confused about.
So,
Because like, aren't you passing?
oh, okay. So I think this is something in key value pairs. Keys are always string. So if the thing that's passed is a key into the key value pair is not a string, what JavaScript does is the toString method on it. So we've gone ahead and hijacked toString
That makes sense.
and then converted it into whatever this variable is. So it's a bit of hijacking, because under the hood, whenever a key is not a string, JavaScript says, I'm going to turn you into a string. You know, it does the same with variables, but we don't want update user object to string to be update user object like it normally would. We actually want it to be this. So it's a little bit of a pattern. And I just use it so much. What I like about establishing a pattern, the downside is it can be hard to read other people's code because you get so used to the pattern that you use. Because at this point, I know I wrote every single line, but I usually just copy paste and then change everything that I want to change. You know, I just go like this, Control D, boom, 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 you know, update whatever I want to update, and just go through the whole thing. But it is good if you ever find yourself that you need to write out a string in two places, you want to hold it in a variable so that you never have to update two things at once. So that's another pattern for your Redux store. Now, I think the only way that the syntax is going to make sense is when you start using Redux. But now I want to go back to kind of the pattern. So anytime the data that's going to be shared across screens